Today we will discuss about action potential. What is action potential? Action potential is a change in membrane potential. It is a rapid change in membrane potential. To explain in detail about action potential, we have a graph in here. We have plotted membrane voltage membrane voltage on y-axis and time on x-axis. Let's say we give a stimulus to a nerve cell. When we give a stimulus to the nerve cell, the membrane voltage increases slowly with respect to time until it reaches a particular membrane voltage. From that membrane voltage or from that membrane potential, the membrane potential rises rapidly. We can notice from resting membrane potential to that particular voltage, it rises slowly, and from that particular potential, it rises rapidly. We call this particular voltage or potential as threshold voltage. How the membrane voltage progresses, you can see from here. It rises rapidly, it reaches a particular point, it doesn't grow from there on, it stops at a particular point and then it falls rapidly. It goes back to its resting membrane potential, it doesn't stop there. It still goes downwards, that is the membrane voltage still decreases until a particular point and then it returns back to its resting membrane potential. The rapid rise in membrane potential starts at this point called threshold voltage and then it reaches back to its resting membrane potential. This change occurring from threshold voltage to the point when it reaches the resting membrane potential, this time period or this change is called action potential. The change in which there is a rapid rise and then a fall and then the membrane potential reaches back to resting membrane potential is called action potential. Okay, we see the definition here. Action potential is defined as sudden, rapid, transient, propagating change in membrane potential. Why it is rapid? Because the duration of the action potential is only 1 millisecond. That's why we call it as rapid. We call it as transient because from the resting membrane potential there is a change, and when it reaches threshold voltage, the action potential fires or the action potential starts, we say, and it reaches back to resting membrane potential. So it is a transient change. It returns back to its original state. It is a propagating. That is, it doesn't decay over time. It fully propagates. When it, let's say action potential is fired in a particular cell, it transmits to other cell, transmits to other cell, transmits to other cell, and it transmits over the entire length of the axonal membrane. That's why we call it as propagating. So we define action potential as sudden, rapid, transient, propagating change in membrane potential. In this graph, we can also see there are 4 phases. We divide action potential into 4 phases. We see from the threshold voltage to a point where the membrane voltage doesn't grow. To that point, we call this phase, the rising phase or the rapid phase, as depolarization. What is depolarization? Depolarization is a change in membrane potential towards positive value. A change in resting membrane potential towards positive value is depolarization. Next is the peak phase. And peak phase, you can see that there is no growth from here on. It attains a peak value. That is, membrane voltage attains a peak value. It doesn't grow from there on. This is the peak phase. And number 3 is this fall. This is called as repolarization. That means repolarization. It again tries to attain the resting membrane potential. Re means again rebacking. So it again wants to go to resting membrane potential. Okay. Now it goes to resting membrane potential. That phase is completed, and it doesn't stop there. The membrane potential falls down again, and it again rises to resting membrane potential. This phase, that is still decrease in membrane potential, is called after hyperpolarization. Hyperpolarization means a negative change in membrane potential is called hyperpolarization. A positive change in membrane potential is called depolarization. As hyperpolarization is produced after the membrane potential reaches the resting membrane potential, it is called after hyperpolarization. Okay. Now you can ask me, what are these dots? Okay. These dots are known as Graded potential. We will discuss this thing. Say if I introduce the stimulus to a particular neuronal cell, the membrane voltage increases with respect to time. If the membrane voltage reaches a particular threshold, then there is a rapid increase in membrane voltage. We can see it follows a particular pattern, and this change is called as action potential. What happens if that stimulus cannot produce a threshold voltage. Then that membrane voltage will rise until a particular point and then it will fall down. This change, which doesn't fire action potential, this is a graded potential.